What you get for your money is a calibration plate, which is the backdrop with the circles and the dots on it, a camera, a laser, and the software. The software comes in the form of a USB stick, so you can plug it into any PC or any laptop and use it anywhere. The first thing you have to do is to calibrate the camera. In other words, you have to put the camera in front of the calibration plate and make sure that the software recognizes the position of both. Once that's been done, then you're ready to start scanning any object that you place between the calibration plate and the camera. Here you can see we have a torso which is going to be scanned by my colleague Trupti. So all she does is slowly, using a sort of paintbrush effect, will slowly move the laser up and down the object, and as she does so you will see the object starting to appear in real time on the screen as a virtual file. The camera is basically picking up the light and shade created by the laser and collecting that information on the screen. Trupti can watch the screen and see how much information she has collected, and what she sees there will give her a first approximation as to how much information she already has collected. She will then pause the scanning and click on the button which says Show 3D, and she can now see, by looking at the finished product, how much of the information that is available she has actually collected. And it looks to me as if she's done a pretty good job. The way that the system works is you scan one aspect of an object. Once you have scanned it from all angles, provided that there is a small overlap between each file, the software will then enable you to merge them together, to mesh them, and to create a complete 3D file. In true Blue Peter style, Trupti has already carried out 3 scans of the object from different angles before the one that you've just seen. So we now have 4 separate scans on the screen. There is an eraser function within the software, so what she's doing now is she is removing what is called noise, in other words information that is not directly part of the scan. And you always get that with every scan. You will pick up some noise, some extra information which isn't part of what you're trying to achieve. So in other words, this is basically cleaning up the scan. You will see on the screen that she has the 4 files which she has scanned. They're all the same object but scanned from different angles. And now we turn to the meshing function. She has chosen 2 files and she has brought them together. Once she has brought together 2 files and created a single file from those 2 objects, she will then choose a 3rd one and mesh it with the 2 that are already merged. And providing that we have had an overlap between files A and B, B and C, C and D and so on, then we're able to create a complete merge file from the separate scans. You will see on the screen that there are still some holes in the file, and this happens with every type of laser scanning, whether you're spending a little amount for the David or a large amount for another product, simply because a laser cannot see the object from every angle. There are 2 solutions to solve this. You can either instruct our software to fill in the holes until you get what is called a watertight STL, in other words, a file which has got no holes and which can then be taken from this package and imported into other packages, or which can then be machined or printed directly from this. So if you just wanted to have another torso, either printed or machined, which looked exactly like this one, you would just go straight to the output. If, however, you just wanted to use this as the starting point for another design, you would take the file and import it into a 3D CAD package or into our Chameleon package. The size of object with the system can vary depending on what you want to do. You will see on the calibration plate that there are two sizes. There is the very small size, which is for tiny objects, and the smallest object that we know of which has been scanned using the David laser scanner is a fly. And there is the larger calibration section which we've used for our torso. You also get a still larger calibration plate for larger objects, or if the object is too large for a background such as the one that we show here, it also comes in PDF format so that you can print it out on a large format printer and then put it up, say, in the corner of a room and put the object between the camera and the PDF. The largest object that has been scanned is an 8-meter boat. So although this may not be the best system for scanning such huge objects, it can be done. All our products are the lowest cost that we can find anywhere in the world, and that's certainly true of the David scanner. You can find laser scanners from any price between £2,000 up to about £70,000, which doesn't minimize its efficiency and efficacy, it just makes it very accessible. The David laser scanner starter kit, which comes with a webcam and a red laser, gives a resolution of around 200 microns. Alternatively, you can use the equipment which we showed in this video, which is a black and white camera plus a green laser, and because of the higher resolution of the camera and the fact that a green laser has a shorter wavelength, you can get a resolution, depending on the object which you are scanning, of below 100 microns.